Hey, also this is Math 116, section 4.3, the Simplex Method, and this is another section of linear programming and maximization problems. So it's the exact same problems we did in 4.2, but we're doing them a different way. And this is the more algebraic way versus in 4.2 where we had the graphical solutions. So let me remind you of 4.2. So here's an example of a 4.2 problem. We're going to maximize this objective function with these constraints. And so what we would do is we would graph all of our constraints and then figure out where our feasibility region is. And then remember the corner points were the points where the maximum would occur. And we just took all those corner points and put them into our objective function and then just figured out which one was the biggest, and then that's where our maximum was. So in this case, it happened at this point right here, 2, 4, and the maximum for the this function was 22. So we're doing that exact same thing. It's just instead of graphically, we're going to do this with matrices. And where this is good is graphically is fine if you only have 2 variables, because then you're just graphing the lines. But anything larger than that, 3 variables, now you're in 3-dimensional space, 4 variables, you can see that would get really dicey. You can't really see the graph. So we need another method for these cases that are more involved. So this section comes with a lot of vocabulary. And so I'm going to kind of bounce back and a lot of steps. So not an easy section at all. I'm going to kind of bounce back and forth between this page with all of our definitions of our terms and our steps and an example, because I think if I just read all this, it would bounce right off your brain. But we sort of need it in the example. So I'm going to kind of just, on this first example, kind of jump back and forth between them. Okay, so the first of our definitions is going to be slack variable, the variable used to convert the constraint inequalities to equations. So the slack variable represents the amount of the constraint resource left unused. So that's a situation where maybe we had so many computer chips and so many assembly hours, and the way that we made the most money was to not use all the computer chips, and so we'd have this kind of leftover quantity. Okay, so step 1 of 8 in this is create slack variables to convert the constraint inequalities to equations. So looking at our first example, I did that step already. So here's our constraint inequalities, and then what I'm saying is this first equation, we're going to have a slack variable that I'm calling S1, and now it's equals, it's an equation. And likewise, same thing here, I'm putting in an S2 and making that an equation. Step 2, write the objective function equal to 0 with the terms involving variables as negatives. Okay, so let me show that. So here's our objective function. And so we're supposed to write this equal to 0, and we want the variable ones to be negative. We want the f to stay positive. So that will look like negative 4x minus 3y, and then plus f equals 0. Okay, step 3, make a simplex tableau with the constraint equations with the slack variables from step 1 in the upper rows and the revised objective function, step 2, in the bottom row. And I'll show that in half a second. So the simplex tableau, again, here back to our definitions, it's a matrix with constraint equations in the top rows and the objective function in the bottom row. So pretty much this is telling you to make that. So let me show you what that would look like. So we want our constraint equations first. And so if I write this as a matrix, and we're going to have 3 equations this way, and then let's label our columns. We're going to have x, we're going to have y, we're going to have slack 1, we're going to have slack 2, we're going to have f, and then we're going to have our equal sign. So for this first equation, we have a 1x, so that makes a 1 right here. We have a 2y. The slack equation, the slack variable is a 1. This equation does not contain slack variable 2 or f, so these are both zeros. And we bring a line down, that's our equals, and that would be 8. So then our second row is going to be our second constraint. So x is 2, y is 1, doesn't contain s1, so 0, does contain s2, so that's like 1 s2, doesn't contain f, only this equation contains f, so that's 0, and that will be 10. And then the revised objective function will be negative 4 on x, negative 3y, no slack variables, but a 1 on the f, and that equals 0. So this is my Simplex Tableau, and we usually have a line here for the equals, and then we have a line here separating the constraints from the objective. Okay, so next up is all these steps involving the pivot. So what the pivot was back here. We're starting at 0, 0 when we set up our Tableau, and then we're going to figure out, using these next few steps, which direction we're going to go, and then we're going to basically check one of these points. It'll be algebraic, and then if that one doesn't work, we go again and we check the next point until we hit the maximum value. So what the pivot does, we're going to have a pivot column, so the column with the most negative number in the bottom row. And step 4, select the pivot column by finding the most negative entry in the bottom row. So right here, we look at our bottom row, the most negative entry is negative 4 right there. So then this is our pivot column. Okay, step 5, select the pivot row by dividing the last column by the corresponding entries in the pivot column. And I'll show that, it'll make way more sense. The row with the smallest positive result is the pivot row. And the pivot row definition is basically just that again. So what we're going to do is we're going to divide the last column by the value in the pivot column. So this would be 8 divided by 1 would be 8, and then 10 divided by 2 would equal 5. And so then we're taking the row with the smallest positive result is the pivot row, and so that's going to be the 5, and so that makes this the pivot row. So then that gets us to the pivot entry. The entry in both the pivot row and the pivot column. So this is going to be our pivot, and that's step 6 is to find the pivot. So that for us will be right there. Okay, now that we have the pivot, we're back on step 6. We found our pivot. Divide the pivot by itself or multiply by the reciprocal if it's a fraction. So in other words, we're trying to make it 1. Obtain zeros for the rest of the entries in the pivot column using row operations. So over here, what we're going to do is we need to make this 2 a 1. Whatever the pivot is, we want that to be 1. So we're going to divide everything in this row by 2, and that's going to make this a 1, and then we're going to use that 1 to knock out the 1 and the 4. So let me show, on this page, I'll show dividing this by 2, and then that will get us our new Tableau. So this is going to stay 1, 2, 1, 0, 0, 8. And then here we're going to have divide by 2, it makes 1. Divide by 2, and I get 1/2. Divide by 2, still 0. 1/2, still 0. And then 10 divided by 2 would make a 5. And then down here we still have this. So that's the matrix that I'll do row operations on now. And what I'm going to do, so again, my pivot was right here. So I'm going to multiply -1 to this row, add it to this one, and that's going to knock out that. And my goal, remember, is to get zeros everywhere in the pivot column. And then I'll do this by 4 and use it to knock out that. Okay, so I'm going to go negative row 2 and then add that to row 1 to knock out the 1. So negative row 2 plus row 1 will make my new row 1. And I'm just going to show all the scratch work over here and then put it back together when I'm done. So negative row 2 will look like -1, -1/2, 0, -1/2, 0, and -5. And then row 1, I'll just copy that down. So 1, 2, 1, 0, 0, 8. So putting those together, I get 0. 2 minus a half would leave me 1 1/2, or 3 halves as a fraction. 0 and 1 for 1, negative 1/2 there, 0 and 3. So that's going to be my new row 1. And then I'm going to go 4 times row 2. And I'll add that to row 3. That's going to knock out that negative 4 and get me a 0. And that will make my new row 3. So 4 times row 1 will be 4, half of 4 will be 2, 0, 2, 0, and then 4 times 5 for 20. And then row 3. And then add these up. And then that becomes my new row 3. So I'll rewrite all that and then cut back and kind of show it. Okay, so here's our new tableau with our new row and our new row 3 put in there. So this just went here. This was our old row 2 from the last matrix. And then there's our new row 3. And unfortunately, we have a negative value here. So if you remember back in the directions, we just did step 6, and now we're at, so we obtained 0 entries above and below the pivot. And now if all the indicators in the bottom row are positive, go to step 8. If there's still negative value or values, repeat step 4 through 6. So this is a bummer because we do have a negative, which means we have to do all of that again, and so we have to repivot so that we tested our first point, that this is negative means it's not optimized, so we keep going. And so we do that exact same process. We're just going to find our new pivot. So our pivot column is going to be right here, because that's the one with the negative in it. And our pivot row, remember we do that by dividing the equal side by the value in the column. So this is going to be 3 divided by 3 halves, which we can think of as 3 divided by 3 halves, and then flip it over. So 3 divided by, times 2/3. Those cancel and I get 2. And then 5, I'll just write it, divided by 1/2 is the same thing as 5 times 2. Let me flip it over. So that would be 10. So this one came out 10, and 3 there came out 2. So this is my smaller value, so that makes that my pivot row. So then, there's our pivot row, and so this entry right here, that's going to be our new pivot. So what we want to do is multiply this by 2/3, because that's the reciprocal here. And so if I do this by 2/3, that's going to make this a 1 and mess up all this stuff. But let me show that. So I'll go kind of think of a little 2/3 right there. So 2/3 times 0 is still going to make 0. 2/3 times 3 halves, there's the 1 that we want. And then this will be 2/3, 2/3. 2/3 times 1/2, the 2's would cancel, leaving me negative 1/3. 2/3 times 0 is still 0. And 2/3 times 3, the 3's would cancel, leaving me just a 2. So this is my new row 1. And then what we would do is just write these 2 in, and I'll go ahead and cut away for a second and get that set up. And so again, right here is our pivot. And so we're going to have to do negative 1/2 to this to knock out this. And then if we just do this plus the 3rd row, that will get me a 0 down there. So again, once we get our pivot, we're trying to get the other 2 to be zeros. So first off, we're going to go negative 1/2 times row 1. I'll give you negative 1/2 here, and I'll knock out this 1/2 there. So plus row 2 is going to make my new row 2. Again, everything I'm just showing to the side here is kind of the scratch work, but hopefully it just makes it easier for you guys to follow. So negative 1/2 times this, so that will be a 0. Negative 1/2. Negative 1/2 times 2/3, the 2's would cancel, leaving me negative 1/3. And then negative 1/2 times negative 1/3 will make positive 1/6. Times 0 is still 0. And negative 1/2 times 2 makes negative 1. and I'll just copy this row below. Okay, and then adding these, I get 0 and 1 for 1. Those cancel out, which is what we're trying to do, is get that 0. 1/3 right there. 1/6 and 1/2 would be 4/6, so 2/3. 0 and 0 is 0, -1 and 5 for 4. And then next, I'm just going to do row 1 plus row 3. And that's going to make my new row 3. Okay, so I just copied row 1 here and row 3 here, and I'll add them. So 0 and 0 for 0. There's that 0 we're trying to get. 2/3. -1/3 plus 2/3. So this would be 6/3, and the -1 would be 5/3 left. And then 0 and 1 for 1, and that makes 22. Okay, and now I'm going to just cut away again and then rewrite this matrix with my new row 2 and row 3. Okay, so here it is with the new row 2 written in and the new row 3 written in right here. And so that got us past step 7. If all the indicators in the bottom row are positive, go to step 8. If there's still negative values, that's where you'd have to repeat. And so here we have all positive values. And then a couple more definitions. So basic variables, variables with columns containing 1s or 0s, except for the objective function row. And then non-basic are variables with values containing something other than 1 or 0. And so our answers are going to be from our basic variables. So if we look here, this one is all 0s and 1s. This is 1s and 0s. And then that's 1s and 0s. So what this means is this is our, remember this is our x, our y, our S1, our S2, F, and then the values over here. So y, so 1y equals 2, because that's in the y column. X, so there's our 1 for our x, so x is 4. These are non-basic, so we didn't need the slack variables this time, but sometimes you do. And then our f, which is what we're trying to optimize, is maximized. The maximum for that is 22. And that is one problem. So I'll do a couple more examples. Okay, so example 2. So same thing, except this time we have 3 equations instead of 2 equations. So that means we're going to need 3 slack variables instead of 2 slack variables. So just to label our columns, we're going to have x, we're going to have y, we're going to have an S1, an S2, and an S3 this time because of that third equation. And then we're also going to have this f, remember, and that will be our line and our equals. So let's get this written in this form. So here we'd have -1, 1, and then S1 will go with equation 1. So 1 and then 0's the rest of the way. And then there's our line, that's our equals, and 2. And so this one will be 1, 2, and then 0, and then second equation, second slack variable, 0's the rest of the way, and 10. Okay, so then our third equation, we have 3, 1, and then 0, 0, and then the third slack variable, 0 and 15. And then we have our objective function, so we're going to bring the 2x and the y over, so that will be a -2 and a -1, and then 0's for the slack variable, this time f is 1, and then that equals to 0. So there is our simplex tableau. So now we have to find our pivot. So remember we do, first thing we do is we look for the most negative value on the indicators, and that is going to be this -2. And then we do the division with the equals column and the pivot column. And then whichever one of those comes out the smallest, that's going to be the one that we want to use. And so For here we'd have 2 over negative 1. And I don't think I mentioned this earlier, but if it's less than 0, then that doesn't count. Here we'd have 10 over 1, so that's 10. And here we'd have 15 over 3, and so that would be 5. So that makes the third row here. That's going to be our pivot row, so then that makes this 3 our pivot. So that means we need to make that 3 into a 1. And so what I'll do, and I'll come down here and rewrite it all, I'm just going to multiply this thing by 1/3, and then that's going to get us a 1 here. Okay, so here's our new matrix with the pivot made 1. So that gave me 3 over 3 made 1, and then 1/3, zeros, 1/3, and then 15 over 3 would give me 5. So now I'm going to use this pivot right here, which is my row 3, to knock out these 1s and that -2 down there. So we're going to have row 1 plus row 3, and that's going to make our new row 1. And then we'll go negative row 3 plus row 2. That will make our new row 2. And then here we'll go 2 times row 3 plus row 4 to make our new row 4. And so I'll cut away and get all that set up and then come back. Okay, so I have all those set up now. So here's row 1 and row 3 for our new row 1. So -1, 1 is going to give us 0. And that was what we're trying to do, is get all these first columns to 0. 1 and 1/3, also known as 4/3. 1 and 0 for 1, 0, 1/3, 0, and 7. And then we're doing the negative of our old row 3 plus row 2 to make a new row 2. So there's that 0 again. And then 2 minus 1/3, so that would be 6/3 minus 1/3, so that would leave us 5/3. Zeros here, 1, -1/3, 0, and 5. And then 2 times row 3 and our row 4 to make our new row 4. So there's the 0 again. -3/3 plus 2/3. Oh, that's no good. So we're getting a negative down there, which means we're going to have to go again. Zeros, a 2/3 there, 1, and 10. So now I'll cut away again, and I'll rewrite all that as a matrix. Okay, so here's our new matrix with all those results from the last page plugged in. So unfortunately, we do have a -1/3 here, and that means we have to pivot again. So that's going to be our pivot column, and then we'll do the division, and so that's going to be a little unpleasant. So this is going to be 7 divided by 4/3, which would be 7 times 3/4. So this first one is 21/4. And then let's see, this next one will be 5 divided by 5/3. So that's really 5 times 3/5. 5's cancel. So that will be 3. And this will be 5 divided by 1/3. And so that's divided by 1/3. And that's the same thing as 5 times 3, so 15. Okay, so then remember that we want the smallest of these values, and that's going to be this 3 right here. So that's going to make this our pivot row. And then pivot column, pivot row. So that's going to be our pivot. And so what that means is now I need to multiply this whole thing by 3/5, because that's going to knock out this 5/3, and then make another matrix out of that. Okay, so I've rewritten the matrix with the pivot as 1. And so again, I took the pivot row, multiplied everything by 3/5, and then that gave me this. And so now again, I'm going to write out what I'm going to do, and then I'll cut away and do all the work and then come back with it. So we're going to use this one to get zeros here, here, and here. So I'm going to go -4/3 times row 2, and I'll add row 1 to that, and that will give me that 0, and that will be my new row 1. And then I'm going to do a -1/3 to knock out this +1/3. So -1/3 row 2 plus row 3. And that's going to make my new row 3. And then down here, I'll just do a 1/3 because I'll knock out this -1/3. So 1/3 of row 2, and then plus row 4, and that will make my new row 4. Okay, so I'll get all of that set up. Okay, so here's all that work set up from the last page. So for my new row 1, I would get zeros here. That cancels and gets 0, 1, -4/5. 4/5 plus, or sorry, 4/15 plus 1/3. And I'll just use this one to kind of remind you how to add fractions. And your calculator is really good at adding fractions. If you find that fraction key, that makes these pretty quick. If not, we can also just do them longhand. So I'm multiplying this one by 5/5 to get a common denominator. So that gives me 5/15. So that would be 9/15. And then I could reduce a 3 from there. So that'll give me 3/5. And then zeros here. And then -4 plus 7 would make 3. And I'll show you on my calculator. Yours may have a different fraction key than this, but just realize that if you have a scientific calculator, it does this. So if I do the 4/5 plus 1/3, so I'd go 4, and then for me it's this little fraction key right here, and you get the little caret. The newer ones, they actually kind of look more like fractions, and so that's over 15, and then I'm going to add to that 1/3, so plus 1 fraction 3. Enter, and then there it is, the same 3/5 I got. So your calculator also does that, so feel free to use that to speed this up. For this next one, we'd have 0, 0, 0, -1/5. This one, I won't show the work on this one, will come out to 2/5. 0 and 4, it's the same ideas right there though. And then our last one was to make our new row 4. So 0, 0, and 0, 1/5. That comes out to 3/5, 1, and 11. And so again, I'll copy all this over to a new matrix and then start from there. Okay, so here it is all rewritten. And this time our indicators were all positive, so that means we have found an optimum solution. And then we look for our basic variables, so those are the ones with 1s and 0s. So here, 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 here. And then these are non-basic, so they don't count. And what that means is, right here, this would be S1. And it's not a part of the answer, like in terms of the homework, but it did mean we did need that slack variable. So I'll just kind of note S1 is 3. But in terms of our answers, here's X, it's 4. And then Y is right there, it's 3. And then F has a maximum of 11. And that happens at 4, 3. So that was the second example. Okay, so probably what really happens in class is by then I've melted all of your brains and you're completely unable to even fathom doing number 3. But that's what would happen next, is now I'd say, okay, it's your guys' turn to try. So here's the matched problem for you. So I'll go ahead and just set up the matrix from here. I've done that a couple of times now. So 2, 1, we have 2 equations, so we're going to have 2 slack variables in that F. So we'll do 1, 0, 0, and then 8. And let me go ahead and label those. So remember, this was our X, our Y, our S1, our S2, and then F, because we're going to bring over the X's and Y's, and then that's going to be our equals side. And then for this next one, this would go 2, 3, 0, and then that has the second slack variable, 0 and 12. And then we'll bring the 3x and the y over. So -3 and then -1, slacks are 0, f is 1, and then that would equal 0. So there is our tableau. And then we got to do, whoops, let me get a line right here. So this is our most negative. So that's going to be our pivot row. Sorry, column. And then we do the division. So 8 divided by 2 equals 4, and 12 divided by 2 would equal 6. So that makes this top one our pivot row. So that's 2 is going to be our pivot entry. So what I'll do is I'll multiply this by 1/2, and then that's going to give me my new row 1 with a 1 in the pivot entry. Okay, so here is my new row 1. So I just divided everything by 2, so it made a 1, a 1/2, a 1/2, and then that 4 right there. So now I'm going to use this 1 to knock out the 2 and the 3 to get my zeros in my pivot column. So I'm going to go -2 times row 1 and add that to row 2. Okay, and so here I just set up all the work. So that'll be, I just multiplied this by 2 and that gave me that. So this will go 2, -1, 1, 0, and 4. And then next I'll do 3 times row 1. And then we add to that row 3. And that will make my new row 3. Okay, so now I set that up. So I just did 3 times this row, and then we're adding this row. So it's going to give me a 0. -1 plus 3/2 will leave 1/2. This will be 3/2. 0, 1, and 12. And so now I'll just rewrite again the matrix with this stuff put in. Okay, so here it is all rewritten. And this time we got lucky and there's no negatives down here, so that means we don't have to pivot again. We've maximized it. And then we're going to figure out our columns that have the basic variables. So 1s and 0s, so that one, -1, no good, that one, and that's it. So this one came out a little bit different. And so what that means is here we have x, and that's going to be 4. And then our other one down here is f equals 12. And so what's up with y is that we don't want any y's. And so it came out non-basic. So in this case, whatever x is and whatever y is, we were better off sticking with just making x's and not doing any y's. And that's what maximized this function. So mercifully, that wraps up 4.3, I guess, until the review.